Okay, today I want to talk to you a little bit about some things you're supposed to know from the past that now we need you to know them again. And I'm going to start with add, subtract, multiply, and dividing fractions. If I had like 1/3 plus 3/4, I can't add them the way they are, right? What do they need? A common denominator. They need something in common. There's so many times in math, this is true, that you need to have something in common before you can be put together. That's kind of true in other situations, like in groups. You ever been in a group and all the people are like so different than you that it just kind of feels awkward that you don't have anything, what, in common, right? If you have things in common with people, like, hey, we're both on the track team, or we're both athletes. Okay, you got something in common. You need something in common to be able to get along. Okay, if you focus on your differences and stuff, you just aren't really interested in like coming together. Well, the same thing with fractions. They need to have something in common. All right, this is also true like with inches. If I had 30 inches and 3 feet, I can't put them together and make 33, can I? Because I may have to make them have something in common first. They have to have their units in common. So I could say 36 inches. Now they'll have something in common. All right, this happens so much, and as you look at math from that perspective, that you need to make things the same so that they can kind of get along. Happens even in trigonometry. You'll learn that next year. Okay, so 1/3 plus 3/4, I'm going to use 12ths, but I want you to really think about what's happening here. I don't want you to say, oh, 1/3 is 4/12. How are we getting 1/3 to turn into 12ths? Yes? And who says I can just times this by 4? Aren't I making it 4 times bigger by doing that? So 1/3 is going to get 4 times bigger? No, it's not. If you think about it. You're right that we multiply by 4. I'm just trying to make you think it a little further. Yes?
I multiply 4 with 1 to get it there. Multiply by 4 with 4.
That's kind of the trick. You are multiplying it by 4, but you're really multiplying the top by 4 also, which really means you're multiplying by 4 over 4, which really means you're multiplying it by 1. Exactly what you said. Good job. So you can multiply things by 1. We didn't change it other than it's going to look a little different, but it's still going to be equal to the same thing it was before, because when you times by 1, it stays equal. So 1/3 changes into 4/12, and they are equal to each other. All right, good. And same idea down here. You're really multiplying it by a form of 1, 3 over 3. And I get 9. And now I can put them together. 9 and 4 makes 13, 12. And this brings up a good point, too. A lot of people think, oh, that's improper. I have to fix it. Make it 1 and 1/12. No, don't do that. I know that the word improper makes it sound like it's bad. You know, your behavior today was improper. Would make you think that you did something wrong. But there's nothing wrong with this. Leave it. Because in algebra, if we have 13/12a, that's a lot easier to work with than 1 and 1/12a. You never will see that. You won't even usually see the decimal for it. You'll see 13/12 a. All right, so the point is, when you have answers today that are like this, leave them alone. But what if it had been like this? 12 over 8. That's bigger on top, and you said to just leave it alone. Not really. You want to simplify it first, then leave it alone. Okay, so 12/8 could simplify to what? All right, so if I was gonna simplify this, do you remember that 12 would be 4 times 3 and 8 would be 4 times 2? You see what I'm going to do here? And I'm going to get rid of the 1. See how that's 4 over 4 is really 1? That's why it cancels. And the answer is 3 over 2. Okay? All right, so, yeah, I want you to reduce things. But then if it's 3 over 2, you can leave it like that. Once it's down to a form where you can't like reduce it anymore, you can leave it as 3/2. Okay, so that's adding fractions. Let's just have you do one, because doing one's different than watching me do one. 2/7 plus 1/9. Add them up. Do what I just did. All right, I'd personally be using 63rds. Now some of you are probably like, it's 9 times 7. All right. And if I'm going to do that, I have to times this by 7, but really I'm multiplying it by 7 over 7. And so this, and then I go like this, and 9. Don't be afraid if I make a mistake to tell me. And 9 times 6 is 18. And 18 and 7 makes 25, 60/3. Anybody get the same thing as I did? All right, good. Okay, so there's adding, and of course subtracting fractions is pretty much the same thing. Multiplying them is easy as pie. 2/3 times 3/8, for instance. But I just times across the top, times across the bottom, I get 6/24. Would there be something smart I could do during this problem to make my answer better? Because 6/24 needs to be reduced. What could I have done earlier in the problem to make this come out to an answer that was reduced in the first place? Yeah, I can. Okay, now, exactly. I'm going to reduce those 3's to 1. I like the way you said that. Okay, because the 3 over the 3 really is equal to 1, so I'm going to replace them with 1 over 1. Is there something else I could do? Yeah, that, yep. Here's what I'm going to do. I'm going to change the 8 to a 4 times 2. That makes sense, right? And then what am I going to do? Get rid of the 2's. And they're going to turn into 1's, technically. And I don't want them to just disappear. Otherwise, if I think they just disappear, there'd be nothing on the top. But there's really little 1's there. 1 times 1 is 1, over 1 times 4 is 4, and the answer is 1/4. Okay? I want you to try one, please. 3/4 times 12/21. Multiply. You can do a little canceling and make it go faster. You already have the answer? Okay, all right. Then what I want you to do, I'm going to pause for a second. Okay, we're back. Had some kids that had to go to bus safety there. Smaller class. Here we go. So if I'm going to get this thing simplified, I am going to say, all right, that 21 could be written as, whoa, that was weird. I moved everything by accident. Okay, let's try again. That 21 could be changed into what? 7 times what? 3, and then the 3's can cancel. Yeah, they usually, it's fine to just cross them off. You don't have to replace them with 1's. It makes your paper look all messy. Just know really that there is a 1 going in there. Because if everything cancels, you don't want to think that there's nothing left. There's a 1 there. Okay, and then this 12 could change into 3 times 4, and then why would that be smart? 4 cancels. Bing, bing, final answer, 3/7. All right, so multiplications are easy, and there is some canceling that you can do in them that makes your life a little bit easier, a little bit better. Dividing is not easy, and it's a real pain in the butt. So I would recommend you never divide. What should you do? You can not cross multiply. Good question, but no, that's only in equal signs. Like then you can cross multiply. Okay, or I should actually have like a variable here. And you can cross multiply on those. This you do not cross multiply. You do some flipping. What do you do with the flipping? So tell me exactly what I should write as my new problem. Yes. Because dividing by a fraction is the same as multiplying by the reciprocal of it. I'll give you the easiest example. Let's say I had 8, and I'm going to divide that by 2. Do you get that that's the exact same thing as 8 times it by 1/2? You see what I'm saying? That's the simplest case of it, but it works on everything. Change any divide into a multiply, and then you take your 5/4, change it to a 5/4. Now this is way easier because now it's just 1 times 5 is 5, over 4 times 3 is 12. The answer is 5/12. Everyone understand? All right. Now, can you see that this is actually the exact same thing? Is it an add, subtract, multiply, or divide problem? It's a divide problem right now. Could I change it to a multiply problem? Yeah, same idea. I could say that this is 1/3 divided by 4/5. But that wouldn't be very easy. 1/3 times 5/4 would be easy. Okay, so you can take any fraction that's in a fraction like this and change it to a multiply problem and flip the denominator over, and that makes life easier. All right, I'd like you to try that right now. Try this one. 3/4 divided by n over 7. We're in algebra here. In fact, we're in higher algebra, so should be able to handle it if I throw in one variable. Three-fourths. And instead of divided by, times, it's supposed to be a star sign there, 7 over n. Final answer, 21 over 4n. Raise your hand if you had it right. Okay, good. Now, I want to stretch you one more time. Remember that answer. Well, you probably have it on your paper, 21 over 4n. I'm going to show you a way to multiply by 1. Remember a second ago we just said multiplying by 1 was okay? So if I multiply by 2 over 2, would you agree that that will not mess up my answer? It will keep it equal? All right. But 2 isn't going to really help me. Guess what number I could multiply the top and the bottom by that would clear my fractions out and give me the answer instantly? Let's take a guess. What number could I put on the top and the bottom that would fix this and give me the answer right off the bat? How about this? Would you agree that the top would get fixed if I multiplied it by 4? Because if I times the top by 4, 3/4 times 4, see how the 4s will just cancel? But it's not 4, because 4 would not fix the bottom. What would fix the bottom? 7. So it's not 7. It's not 4. Come on, you can do this. Yes? 28. If you use 28, watch what happens. Now I'm going to put it over 1. That's the same thing as 28, right? I'm just doing that because fractions play nice with other fractions. And now I'm going to multiply it out. And what will happen is the 4 goes in here once and the 4 goes in here how many times? 7 times. So the answer on top is 21. And on the bottom, 7 goes in here once, 7 goes in here 4 times, and the answer on the bottom is 4m. Recognize that answer? Same exact answer we got before. Calc teachers like this method because there's some tricky calc stuff later that you'll be able to use this method to solve. All right, let me show you one more. See if you can do it yourself. 3/7 divided by 5. Let's go with seconds. Everybody give that a shot. Use the calc teacher method. I know that the other method works, but just it's a cool thing to know a different way. Sometimes the different way ends up working out way easier. All right, so what are you multiplying the top and the bottom by? 14. Why do I have the 14 twice? Because I have to have it the same exact thing on top and the bottom to make it equal to 1. You know what I mean? What's here has to be the same as what's here. That way I'm multiplying by 1. Okay, 7 goes in here once, 7 goes in here twice. 3 times 2 is 6. 2 goes in here once, 2 goes in here 7 times 5 is 35. Answer 6/35. Raise your hand if you had it right. Okay. I learned something you're going to actually use in calc now, except that it's much more difficult fractions. There'll be fractions that have factoring in them. You'd have to factor stuff out, and then you'd multiply by the common denominator, except it'd be like 4a, or it'd be like x plus 1 squared or something. And you'd multiply that by that on the top and the bottom. It'll make things cancel. So this is like the easy version of it, but you can see how it works at least. Okay. Next thing we got to talk about is what you're going to need to know for the end of your packet. Okay, one of the things that comes up is parallel and perpendicular. If I have two lines that are parallel, that means they have the exact same what? Slope. Okay, and if they got the exact same slope, if I said this one was y equals 3/4 x plus 2, and this one was y equals 3/4 x plus 5 or something, then if they've got the same slope, you can know they're parallel. So I could even, without not even having the picture, I could have just looked at these two and said that they're parallel, right? What would it be if they were like this? perpendicular is correct. If the two are reciprocals and the opposite, two slopes, then it's a perpendicular situation. All right. Now, when would you need this? Well, if they give you a point and they give you a slope, is it a big surprise to you that I'm going to tell you to use the point slope form of the equation? Doesn't that make sense? What if they give you the slope and they give you the y-intercept? Guess which equation I'm going to recommend you use? Slope-intercept, okay? And standard form, it isn't as snappy, it doesn't have the name built in, but standard form is really good for when you have x-intercepts and y-intercepts, okay? So, let me show you what I mean. If I know this spot and I know this spot are on my line, doesn't my line have to go right exactly there? So if I know the x and the y-intercepts, you pretty much got a lock on where the line is. So if you have this kind of a thing, 3x plus 2y equals 12, and I want to know where my x and y-intercepts are, it's not as simple as just saying, oh, that's the x-intercept and that's the y-intercept or something. It's not like that. But you have to know a little saying that I want you to write in your notes right now. It's like one of the good little gems. Like if you're going to write this down and use it probably 10 times this year. That the y-intercept is where, and don't say where the line touches the y-axis. That's not what I mean. The y-intercept is where, can anybody finish that? The y-intercept is where, yes? Yes! For x? Oh, nothing popped up in this thing. X equals 0. And the corollary to that, kind of goes right with that, would be what other logical statement would follow? The x-intercept, yes, is where y equals 0. So let's use that to do that other problem. Look kind of like this. I don't know if I had it backwards from this or what, but it's the same idea. If I had to find the x-intercept or the y-intercept, I can just set one of them equal to 0, and it's easy as pie. Here's how I would want you to show your work on this. Let's say this is on your homework, which it is, and you have this green equation, and they say find the x and the y-intercept. Then I would go like this. And I go like this. What did I just do here? Yep. I set x equal to 0. And over here, I set y equal to 0. And for this one, if I'm setting x equal to 0, what am I finding? Come on, if I set x equal to 0, what am I finding? The y-intercept. So then I go 3y equals 12 and y equals 4. So what did I just find? The y-intercept, because x was 0. And over here, if y is 0, what am I going to be finding? X-intercept. And so it'll be 2x equals 12 and x equals 6. And I just found the what? The x-intercept. Here's the x-intercept. Here's the y-intercept. Now, technically, the x-intercept is a point. So I really should write the answer as something comma something. And same with the x-intercept and the y-intercept are both a point, something comma something. But if I just use what I know the x-intercept is where y is 0, then the 6 can only go one other place. Duh, that's easy. And here, the y-intercept is where x is 0, and then the y has to go in the other place, and there we go. Okay, so that's how you, when they give you an equation, even if it's an ugly, nasty equation, and they ask you what its y-intercept is, that's how you do it. So here would be a typical, this would be too easy. If they said, what's the y-intercept? You'd be able to go, oh, what is it? 5. But if now you can see what I was talking about before, that it's where x equals 0. Y equals 2, 0 plus 5, and then that cancels, and there would be y equals 5. That's the way to show it, instead of just know it. because they aren't always going to be so nice. Sometimes they're going to be like this, 2x squared plus 3y minus 7 is equal to 22. What's the y-intercept? Do you just see it? I bet you don't. But if you just follow what I just told you a second ago, it'll be easy. To find the y-intercept, what are you going to do? No, just finish the sentence. To find the y-intercept, you set x equal to 0. Put a 0 right there. So that's all gone, right? And now I just solved that and I'll have my answer, right? That's all there is to it. So if you want the y-intercept, set x equal to 0. If you want the x-intercept, set y equal to 0. All right. Last thing, if I'm going to give you a point and a slope, and I say the point is 2 comma 3, and the slope is negative 5, could you write the equation for it? Good. Do it. If you don't have this thing memorized, you better memorize it now, because it's going to come up a lot. Okay, so it's y minus 3 equals negative 5 times x minus 2. Now, some kids ask, can we leave it that way? Yes, you can, because the directions on the worksheet you have just say write an equation. They don't say write an equation that starts with y. They don't say write it in this form. If they just say write an equation, that's an equation. I think some people think that they're not done until they solve it for y. You can solve it for y if you want to, but it's extra work. You've already got an equation. And it's a perfectly good equation. It's an equation that tells me the slope, and it even tells me a point, that point and that point. But what if they asked me now, what's the y-intercept of this equation? What would you do? Make x 0. What if they said, what's the x-intercept of this equation? So y equal to 0. All right. Good. I think you've learned everything that you need to know for this worksheet for today. So at this point, we're going to be grading some homework. Okay, I got one more thing I got to say. And that's sometimes they're going to give you a point and a slope in a funny way. They might not just come out and say the slope is 6. They might give you a point of like negative 2 comma 7, and then they might say that the slope is, we want it to be parallel to this other line. So see how they're really telling you a slope by saying that? So you still should use point slope, because they're just telling you the slope in a funny way. So they told me a point, and they told me the slope is right there. So they're still telling you a point and a slope. You still use point slope. So on this one, you do y minus, and y sub 1 is 7 equals slope x minus negative 2. I prefer that you not leave 2 negatives like that, but it's right. But in the end, I'd like you to change that if that happens. Go plus. Okay? All right, so sometimes they're going to give you the slope in a funny way. Sometimes they'll say perpendicular to whatever. Okay, now we're really done.